And we're live! Hi everyone. We were going to theme the whole week about COVID stuff, but then I was like, you know what? It would actually be more fun to just do some random stuff. Today we're doing hares, which if you don't know is kind of like a rabbit, but taller, prouder, and more professional. If you're just logging on for the first time, then know that you can ask questions whenever you want. If you ask me a good enough question at the beginning, then the whole live will just go in a totally different direction. Today's lesson is going to be about hares, and it's also going to be about space. What is a hare parliament? What do people think a hare parliament is, or a parliament of hares? I've heard a lot of people talk about over the years, and it's kind of a mysterious thing that happens in the countryside, apparently. And what do people think it is? So what do people think a hare parliament is? So Japan Maple has said that the hares are going to get together and decide who gets to eat the grass, which is fair enough. Pumpkin Master says a political building run by rabbits. So Hare Parliament is this gathering that happens in the countryside of hares. The story goes that people see a load of hares sat around in a circle, all looking in at one another, supposedly in silence, and then they kind of stay there for a while, and then they all run off in different directions. And this is obviously a representation of your like circle of hares all hanging out, supposedly chatting, although this one seems to have some getting married in the middle or whatever. There's your circle of hares. I don't know, I'm really skeptical about whether this is an actual thing. I spent a while looking online for like hare parliaments and I found zero evidence. Has anyone ever seen that graph? The graph is reported miracles versus time. You got your miracles over the period of time, so looking over history. How many miracles have been reported at different eras? Obviously, if you're going back to your 2000, 3000 BC back here, don't know how good the records were back then for miracle keeping. It's pretty important to record miracles, so they probably had a book or something like it. The idea goes that, you got loads of miracles reported, and then suddenly all the miracles disappear because something is invented, and that something is photography and filming. And suddenly no one reports any miracles anymore. And then the idea is that the chart kind of carries on like that and then spikes back up again because something else is invented. What do people think that might be? Thanks so much, Mia, for saying that you like the videos that I'm doing. Yeah, what do people think the thing is that's been invented that brought all the miracles back? Photoshop, exactly, yes. And thanks to Photoshop, all the miracles are back. This is not a thing that I've seen any concrete evidence of, a hare parliament, but if anyone finds it, send it in, because I'd love to see some. The thing about it that's cool is this idea that animals sometimes get together and discuss things and vote on something. Does anyone know how, this is an African dog, cute little lad or lass. African dogs also have like a voting system where they'll come together and they'll all hang out. In fact, does anyone know how they vote? I'll let some people have a guess. I want to see what people think. Okay, so someone says they put their paws up. We'll see what other answers come in just while I add roller skates. Food, voice, ears. They vote by sneezing. They vote with their sneezes. And sneezes are really important for dogs. If you have a dog, then you'll notice that your dog will sneeze at you if it wants to play with you. And it will also sneeze to show you that it's not trying to kill you. Theoretically, a dog could be really dangerous. And the way that it reassures you that it's just hanging out with you and just wants to play is by sneezing. And African dogs vote in the same way. So they'll stand around, they'll have a serious chat about a complex political issue, and then they'll all sneeze at one another to decide on the outcome. That is actually all true, apart from the bit where they stand around and have a chat. I actually don't know how they exchange the information. But something that is really cool is it's the female dogs that have had the most children, so the biggest matriarchs, who get the biggest votes, so their sneezes count for the most. So pretty cool to be a matriarch female African dog. Why on earth am I talking about all this when I said I would talk about space? It's because of this. Okay, what I want you to do now is imagine that there is a circle of rabbits or hares. Let's just say it's a circle of hares. And the hares are all stood around in this circle and they are all just chatting to one another as with the normal parliament proceedings, whether inside or not inside the parliament building. What happens is suddenly, in an instant, you appear in the middle, like this. And instantly, all of the hares turn around and they all run away. And they all run away at an equal speed in perfectly opposite directions, going as far away from you as possible. What you would see, I want you to imagine what you'd see if you're in the middle of this group. If you're stood in the middle here, what would it look like? the Pumpkin Master has asked what the African dogs vote on. They were voting on like food, where to move the pack next, how to access food, just dog stuff. People think that we'd see these hares running away. Yes. The key thing that I want you to think about is that if you're stood in the middle, then all the hares are going to be running away from you at the same speed in every direction. And maybe that seems like too obvious thing for people to answer, but that's because what we're going to do now is I want you to imagine something different. So instead of you appearing there, what happens instead is you appear inside this hare's brain, and suddenly you can see what this hare can see. And at the same time, someone else appears in the center and scares all the hares away, and they all start running in the same way. Now you're inside this hare, you can feel yourself running away, and all the others are running away as well. You turn around and you look back, and what do you notice? What's the key thing that you notice about the other hares running away? There's something kind of special about the way that they're moving. Have a little think about that. The thing that you notice is that the hares that are closer to you, so let's take this hare here as a close one and this one as well, they're moving away from you, right? So when you're here, they're this far apart. And then when you're both here, you're this far apart. And then when you're both here, you're this far apart, right? So you're getting further away from one another as time goes on. But let's now compare that to the hare over here instead. So let's label this one in orange. So the hare over here, to begin with, you're further apart, right? And then as you both move further away, you're going to be even further apart. And then as you both get out here, you're going to be really, really far apart. So the key thing that I want you guys to notice is that there's this really, in fact, let me see what people type in the chat. What is the relationship? What's going on here? Japan Maple says that she doesn't have any hare friends anymore because they've all run away. The point is that these two hares are close together, and because they're close together, the speed at which they seem to be getting further apart, these two are getting further apart from one another, but actually quite slowly. After all this time, they're still only this far apart. Whereas the hares that were furthest away from you at the beginning are getting far apart from you really quickly. This is one of the most important, if not the most important, relationships in when you're studying the universe. The relationship is that the further away something is, the faster it moves away from you. The more distant something is away, the faster it'll move away from you. If you imagine all the planets as as hares and they're your hare friends, then that's kind of what's happening in the universe, is that everything is separating out and everything's getting further and further apart and more distant. This isn't always the case. Can anyone think of an example where this isn't happening, where the opposite is happening? So examples of things that are moving close together in the universe. Sometimes we move close to the sun, but in general, everything is moving further apart. But there are some really notable exceptions. So for example, the closest galaxy to us is this galaxy called Andromeda. And this is what the Andromeda galaxy looks like. I'll put a circle around it. In the night sky at the moment, on a really clear day. I think you can only see it in the southern hemisphere, but this is what it looks like on a really clear day. This is like an artist's representation of what could happen over the next few billions of years, but actually it goes longer than the human race we think could possibly survive on the planet. So this is unlikely to be what we actually see, but still. Over the next few billions of years, the Andromeda galaxy will get closer and closer to us. And eventually it will literally collide with our galaxy, which you can see in the night sky as the Milky Way. And eventually the two of them will collide and smoosh up with one another in this way. Question. Let's get some estimates in the window. How many stars do people reckon will collide with one another when these two galaxies smash into one another? Japan Maple guessed 0. Yeah, that's exactly right. We think there'll be about 0 collisions. So good. Even though galaxies are really full compared to space, they're actually really, really far. All the stars are really separated. Think about how close our nearest star is, apart from the sun. It's so far away. And so when the two galaxies collide, we think that actually it'll be fine. It'll just be kind of smooshy in the sky, but actually it'll be totally chill. And if anything, we should all be looking forward to it. So yes, some things in the universe are moving towards one another, but most things are getting further apart. Now, there's this guy here called Hubble. He's called Edward Hubble. I can't remember his first name. I think it's Edward, but let's just call him Hubble. Does anyone know any cool bits of equipment that are named after this guy? Yeah, telescope, exactly. So the Hubble Space Telescope is this telescope that's orbiting the Earth, and the reason it's so good is that even though it's actually really old now, like it's ridiculously old, it's like 30 years old or something, it's still giving us the best pictures, the best like, optical pictures of outer space that we have, because the atmosphere is just such a blurry. Looking through the atmosphere to try and see space is like looking through a frosted window. You just get nowhere near as good a picture. And so the Hubble Space Telescope is still like the dream for seeing stuff. The telescope is named after him because he came up with this really cool idea called the Hubble constant, or the Hubble number. And I'm not going to tell you what the number is itself, because you can look it up if you want. It's all on the internet. But the Hubble number just tells you the relationship between how far away something is in space and how fast it's probably moving away from you. Because if something's further away, it's moving away from you faster. And so this is one of the things that we have to get our head around when we're thinking about exploring space, is that if you want to go and visit something that's really far away, it's so much bigger of a challenge, not just because it's further away, but also because it's moving away from you really, really quickly. And so this is one of the reasons why we just have to accept that so much of the universe is just really, really hard to explore. And this is why we have the concept of the observable universe. I don't know if anyone's ever heard of that, but the observable universe is the size of the universe away from us, where it's so big that everything at the edge is moving away from us so quickly that we can't even see it because it's moving away so fast. This is a hydrogen atom. Now, some of you will have done this in school, where you basically draw a hydrogen atom as the nucleus. So this is the center of an atom of the element hydrogen. And then orbiting around it are these shells, these paths of orbit. And it's not that the electrons are actually exactly orbiting, but it's like a good way of thinking about it. So these things called electrons are then swinging around the hydrogen in orbit. Something that you learn actually quite late in school, but I don't think it's too complicated an idea for people to understand. So I'm gonna just throw it at you guys and see how it goes. Is this. So you've got an electron that's really close to the hydrogen. Electrons are negatively charged and the nucleus is positively charged. So it's attracted to the center. It wants to stay near the center. But if you fire a beam of light at this electron, it will get excited. And what I mean by that is it might jump up to the next energy level and then it'll be up here instead. The weird thing about this is that for this to happen, this light that's coming in needs to have exactly the right energy to do this. Exactly the right energy. If the light has too much energy, so if it's just slightly the wrong color, because different colors of light have different energies, if it's slightly the wrong color, then the electron won't go high enough and it'll fall back down. Or it'll go too high and it'll fall over the top and come back down. You need to get exactly the right energy. Now, there are several jumps that the hydrogen can do. It can make this jump here, and that's a specific amount of energy. Or it can make this jump here, and that's another amount of energy. Or it can jump to the next orbit out, and so on. And those are the only things that the electron can do. This means that hydrogen itself will absorb those specific colors of light. So this energy gap here is associated with a specific color of light. And this energy gap is another color, and this energy gap is another color. Now I've actually got them down here to show you. So this is the hydrogen absorption spectrum. So if you look at these different colors, if you were to shine loads of light through a big cloud of hydrogen, then out the other side, you wouldn't have these colors. So this shade of red would be gone. It wouldn't exist on the other side because all the hydrogen will have absorbed it. And same with this shade of light blue, and same with this shade of dark blue, and so on. Now, I'm just going to pause for a moment and see if any people have any questions or if anyone wants me to recap on any part of that. Someone's asking me how many electrons can fit on the third shell. So when you do chemistry at school, you start by saying that the first shell fits 2 and then all the rest fit 8. And that's the first model that you use. And then as you go up a few years, you start to do 2, and then you do 8, and then you do 8, and then you do 18, 18. And basically you take the number of elements in each row of the periodic table. So if you look at the periodic table, you'll see the first row has 2 elements, and the next row has 8 elements, the next has 8, the next has 18, 18, and so on. It's kind of a weird question how many they fit, but for now don't worry about it because you just got 1 electron from the hydrogen that's just jumping up. So people are asking what does it do to the hydrogen? So actually what happens is the hydrogen will just absorb that energy level, because let's say this blue level here is the same energy as is needed to make this middle jump here. It will just absorb that colour, and then when the electron falls back down again, it will just release the energy in another form. It can release it as light as well, but it might release it in another form. And so as a consequence, you just lose this colour. The reason why I'm telling you about this is because this is how we look at distant stars. If you have a big old star in the distance, then you know that that star is super hot, and you know that it's giving off loads of light in every direction. Every star is obviously also made of like hydrogen and helium, so it's got this cloud of hydrogen and helium all around it. Just for now, let's pretend that this cloud is just made of hydrogen. So if you've got a star, and the star's giving off all the colours of light possible, and then all the light has to fly through this cloud of hydrogen before it can reach the rest of outer space, then what happens to the light that's coming off this star? What do people think? Meanwhile, I'm just going to answer another question which came in about, does hydrogen have different properties when it becomes an ion? Yeah, when hydrogen becomes an ion, it loses its electron, and then literally all that's left is just a proton in the centre. So it's a lot smaller than any other ions, and so it actually behaves really differently. In fact, it becomes an acid. So hydrogen losing its electron is what acid is. Yeah, great answer. So the light coming off this star will not have these colours. So you can look at the distant star in space and you can be like, okay, that star is a normal star because we're receiving all these colours at Earth and we can see the full spectrum of light coming back to Earth, except it's missing these. It's missing these colours. This red is missing, this blue is missing, this blue is missing, these purples are missing. It's surrounded by hydrogen, just like all stars. And that's the conclusion we come up with. Now, here's where this gets really clever. This is fire engine. Now, what happens when you hear a fire engine going past? If a fire engine drives past you in the street, what does it sound like? Okay, Mia's spelt it out as a siren. Nice. Exactly. So when the fire engine goes past, it sounds like, and like as it goes past, it shifts to becoming lower frequency. As things made of waves, so light, sound, and all these kind of things, as they're moving really rapidly towards you, they become higher pitched. So as a sound is moving towards you, like a fire engine sound, it sounds higher pitched. And then as it goes past you, it starts to move to lower pitch. And the same thing is happening with these stars. So this star here is emitting all of this light. As you guys correctly said, it's not going to send us these frequencies, right? Because these frequencies are being absorbed. These colours are being absorbed as the light leaves the star. But the thing that we just talked about is that these stars are all moving away from us, right? Or most of them are. So what do you think will happen to these colours of light that appear to be missing? Em said that she thinks that light travels at different speeds depending on the colours, which isn't true. So light always travels at the same speed through the vacuum of space. In fact, it's crazy how consistently it stays at the same speed. Even if you try and distort time and stuff like that, it always travels at the same speed. So it's not to do with that. It's similar to the sound changing of the ambulance as the sound moves, or the fire engine, as the sound moves towards you and away from you, that changes frequency. And as a star moves towards or away from us, the colours that are absorbed change. And so all of these colours will shift in this direction, or they shift this way. And this is called redshift. They shift in this direction. And so the colours that appear to be missing will appear to be further to the right than you would expect them to be, because you know what hydrogen is. And that's happened because the stars are moving away from you. And you can literally look at a star in the distant space and you can measure how big is this shift, how much has the colour changed, and that tells you how quickly it's moving away from you. Because if the star's moving really quickly away from you, it'll shift really far down. And if the star's moving really slowly away from you, it'll shift to there. And in the rare cases that some stars are moving towards us, it will shift in this direction, and that is called blue shift. Almost all stars in the universe are red shifted because they're moving away from us. Once you know how fast they're moving away from you, you can then use Hubble's number to work out what? What do people think you can use Hubble's number to work out once you know how quickly they're moving away from you? I'll see what people think. I think Lily asked, why are some stars moving towards us? So like if you look at the stars in the Andromeda galaxy, they're the ones that are moving towards us. But most stars in the universe are moving away from us. So they're the ones that are going to be redshifted. Yes, okay, so a couple of people said how far away they are, which is exactly right. As soon as you know how fast they're moving away from you, you can work out how far away they are as well, because it's just like the hares that we started with at the beginning. The ones that are further away from us are moving away from us more quickly. And so the ones that are more redshifted, the ones that seem to have the colours of their star shifted more, are the ones that are moving away from us the most. Just in the same way that theoretically you could tell how far away a fire engine is by listening really carefully to the pitch, or how quickly it's moving away from you by listening to the pitch. So if the fire engine is moving away from you crazy quickly, it'll be like whoa, 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 whoa. And obviously the opposite, if it's moving towards you, it would be like beep, 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 beep. Anyway, that's kind of coming to the end of this live, so I'll let people ask any last questions that they might have, and I'll just bring up this picture of a nice Dumbo octopus, which is like a deep sea octopus that just kind of drifts around near the bottom of the sea, just hanging out, just like wiggling its ears. We don't know very much about it. I just want to say thanks so much for everyone who came on board today. Thanks for throwing in so many questions. It really helps with us like making this as good as possible and as fun as possible. Also, if you have any ideas for topics that you want, go on AimHi Live on Instagram and just send messages to there, and then I'll get the topics fed through to me. Spread the word, tell your friends. Thanks so much. We shall see you tomorrow. Ciao.